Okay, let's move on to solving multi-step inequalities. First, however, let's go back to what we've learned so far. If we're trying to solve an inequality and we add or subtract the same number to both sides, then that preserves the inequality. However, if we're going to be multiplying or dividing by a negative number, then the inequality is going to be reversed. That'll come up in some of our examples, and we always want to make sure we can add, subtract, multiply, or divide both sides of an inequality by the same number. However, the one case when we're multiplying or dividing by a negative number, then we have to switch that inequality. So let's look at some examples. Let's solve 3x minus 8 is greater than or equal to 19. All right, just like we spent all that time solving equations, the same process is going to apply here. We want to isolate x or get x by itself, which means we need to get rid of the minus 8 and we need to get rid of the times 3. We usually start furthest away from the variable, so let's undo the minus 8 by adding 8 to both sides. Adding 8 to both sides does not change the inequality. So notice as I'm solving these, I always write the inequality first before I do the actual operations. On the left-hand side, the minus 8 plus 8 is 0, and I'm left with just 3x. On the right side, 19 plus 8 is 27. Now all I need to do is divide both sides by 3, and I'm dividing by a positive number, so that doesn't change my inequality either. 3 divided by 3 is 1, so I have 1x is greater than or equal to 27 divided by 3 is 9. The directions didn't specify what my solution should look like, so I'm just going to leave it as an inequality. X is greater than or equal to 9. If I wanted to show that graphically on a number line, then I'd put 9 on the number line. Maybe a couple more numbers. And then greater than or equal to means I'm including 9, so I'll fill in the circle and go to the right. If I were using interval notation, then I would write it as 9 to infinity, parenthesis around the infinity, bracket around the 9. It means we include the 9. So any one of those three representations would be acceptable. As I move forward, I'm just going to go ahead and use the inequality solution. All right, let's solve a little more complicated one. Negative 2 times the quantity x plus 5 is less than 26. Now you're going to find, just like we did with equations, the more complicated the problem, usually there's more than one possible way to approach it. So most students would probably distribute the negative 2 before they start adding or subtracting and multiplying, dividing to both sides. So if I distribute that, I'm going to get a negative 2x plus a negative 10, or just minus 10, is less than 26. And now let's try and isolate the x. So step 1, let's get rid of the minus 10 by adding 10 to both sides. Adding 10 is not going to change my inequality. The minus 10 plus 10 is 0, so I have a negative 2x on the left side. 26 plus 10 is 36 on the right. Now I need to get rid of the negative 2 times x, so I'm going to do the opposite and divide by negative 2. And right away the warning signs go off. I'm dividing by a negative, so I have to switch my inequality. Negative 2 divided by negative 2 is a positive 1x. 36 divided by 2 is negative 18. So there's my solution. X is greater than negative 18. Now I want to go back though and show you that there is an alternative way to solving this. So what if instead of distributing, we decided let's divide both sides by negative 2 right off the bat. Now dividing by a negative, so I have to switch my inequality. Negative 2 divided by negative 2 is 1, so we don't have to use the parentheses anymore because 1 times the quantity x plus 5 is simply x plus 5. And on the right side, 26 divided by negative 2 is negative 13. Now, one last step, let's get rid of the plus 5 by subtracting 5 from both sides. Minus 5 plus 5 is 0, so I have x is greater than negative 18, which is exactly what I got before. So you decide what works best. Now notice in this case, we were kind of lucky because this number here divided evenly into that number. That's not always the case, and sometimes you can still do it this way, but then you're going to have to deal with a decimal or a fraction. All right, let's do a few more. Let's solve negative 7 is less than or equal to 4x plus 5 minus x. All right, what were the rules when we were solving equations? One of the things we always did was let's simplify each side first before we start adding, subtracting, multiplying, or dividing to both sides. So we can see the right side can be simplified because we have like terms. The 4x minus x I can combine since those are like terms. So I have negative 7 is less than or equal to 4x minus x is 3x, and then plus 5. Now I'm ready to get the x by itself, subtract 5 from both sides. On the left side, and by the way, that does not change the inequality, so it's still less than or equal to. On the left side, I'm going to get negative 12, and on the right side, I'm going to get 3x. Last step would be to divide both sides by 3. That doesn't change the inequality. So on the left side, I'll have negative 4, and on the right side, I'll have 1x. Now, usually we like to, this is fine. You can leave it like that, or if you want to write the variable first, we would write x is greater than or equal to negative 4. And either one is fine. All right, let's try another one. And by the way, just like I've mentioned before, as you're working through these examples, it might be a good idea to hit pause and try and do it yourself first, and then go ahead and hit play and make sure that you were doing it correctly. Okay, let's solve this inequality. They're getting more complicated as we go, which means we have more than one approach. So here I see on the left side, there's nothing I can do to simplify. There's no like terms. On the right side, I could distribute the 5 to get rid of the parentheses. Unlike that last example, the second example, dividing both sides by 5 is not going to result in something that's going to be easy to deal with, because then I have 6/5 times x minus 11/5, and now I'm dealing with a bunch of fractions. So, I mean, you can still do it that way, and it will work out, but it's a lot easier to just distribute this 5 and proceed from there. All right, so I've got 6x minus 11 is greater than 10x plus 5. Now notice this is the first example where we have variables on both sides. There's actually 4 different things we can do here, and you decide which you want to do. When we were solving equations, my suggestion was always, let's try to get the x's together on one side. So what we could do is we could take away 10x from both sides. If you don't like doing that, we could take away 6x from both sides. And either way is fine. We also could subtract 5 from both sides to start, or add 11 to both sides to start. It's totally up to you. The more practice you get, the better you'll understand at what's going to happen, and you'll be able to see a few steps ahead. In this case, I'm just going to go ahead and subtract 10x from both sides. I like to have my variable on the left side. So I'm going to do that, even though the 10 is bigger than the 6. Now subtracting, even though we don't know what x is, we're subtracting from both sides. That doesn't change my inequality. On the left side, 6 minus 10 is going to give me a negative 4x, and I still have the minus 11. And on the right side, the 10x's cancel, and I'm just left with a 5. Now I'm trying to get x by itself, so let's get rid of the minus 11 by adding 11 to both sides. That doesn't change the inequality. And now I have negative 4x on the left and 16 on the right. And finally, let's divide both sides by negative 4. Now I'm dividing by a negative. I can't forget this. It doesn't happen often, but when it does, you have to remember to switch that inequality. And I'm going to get a positive 1x is less than negative 4. And there's my final answer. And regardless of what other ways you decided to solve this, No matter which way you did it, as long as your steps are correct, you should always come up with the same solution. X is less than -4. All right, let's try one last one. Fractions. That's okay, let's proceed the same way. First, let's get the x's together on one side. So I'm gonna do it just like I did before. Let's subtract 1/2 x from both sides. That's not going to change my inequality. Adding or subtracting numbers doesn't affect it. And now I have to subtract 3/4 minus 1/2. Well, if you remember from fraction work, we can't subtract or add fractions unless they have a common denominator. So I need to take that 1/2 and multiply by a form of 1, which doesn't change its value, but now we'll have the same denominator. So we have 3/4 minus 2/4, and that's going to give me 1/4. So 3/4 x minus 1/2 x gives me 1/4 x. And don't forget that plus 1 that's still there on the left. And over on the right side, the 1/2 x and minus 1/2 x cancel, and I have a -7. Okay, let's get x by itself. First, let's get rid of the plus 1. Let's take away 1 from both sides. That doesn't affect my inequality. And now I have 1/4 x on the left and -8 on the right. Now be careful here. Remember, we're trying to get rid of the 1/4. It's being multiplied by x. So we could divide both sides by 1/4, which is fine if you like to think of it that way. But remember, dividing by 1/4 is the same as multiplying by the reciprocal. So that's the same as multiplying by 4/1. And now I'm going to multiply both sides by 4, which again will not change my inequality. Doesn't matter that the -8, that's a negative number. It's the number that I'm multiplying by. If that is negative, then it switches the inequality. But I'm multiplying by a positive 4, so that doesn't change it. On the left side, 4 times 1/4 is 1, so I have 1x. And on the right side, -8 times 4 is -32. So final answer, x less than or equal to -32. All right, now you can try the problems on the worksheet.